Hello everyone, welcome back. Have you ever run two queries on the same table at the same time and get two different answers? No errors, no logs, nothing odd in the logs. That's not a bug, that's Postgres by design. Postgres never really updates a row. It writes a new version and leaves the old one behind. So at any moment, a row can have multiple versions floating around. Which begs the question, how does Postgres know which version your query is allowed to see? So that's what this video is about. MVCC, Transaction IDs, Snapshots, and the 4 rules a Postgres user to decide for visibility. Let's get into it. We first create a simple table. This is a simple bank accounts table, and I'll insert some data into it. So Ali starts with 1,000 rupees and Bob is with 500. Now let's hit this table from 2 sessions at once. Now in the session A, let's deduct the amount from allies. Will not commit it. So here inside session A, allies' balance shows 500, but nobody outside this sessions knows it yet. So let's read the allies' balance at the same moment in the session B. Session B sees 1000, not 500, which is the last committed version. No waiting, no blocking. That's MVCC. Readers never block writers. Writers never block readers. Let's simulate a crash. In the session A, I am going to run rollback. We will check the session B again. It is still 1000. The rollback erased those changes completely and nothing ever leaked out. That's atomicity. The whole transaction happens or none of it does. And we'll look into snapshots. So how does Postgres decides this so fast? Snapshots. The moment your query starts, Postgres takes a snapshot which transactions are running right now and uses it to decide what's visible. So you are seeing something like this, right? That's XMIN, XMAX and active list. XMIN is the oldest still active transaction. Anything older has definitely committed. Safe to read. And XMAX is the next transaction ID not yet handed out. Anything at or above it has not started, invisible. And active list is the transactions mid-flight when the snapshot was taken, started but not yet known to have committed. So these three values and Postgres knows exactly what you can see. So every query takes a tiny snapshot, XMIN, XMAX and an active list, then applies 4 rules row by row, all in microseconds. That's how Postgres gives every session a consistent view of the data with 0 logs and 0 waiting. But if Postgres checks commit status on every row, doesn't that get expensive on a big table? So it is a good instinct. That's next episode. Hint bits, the C log and transaction ID wraparound. One of those things that can quietly bite you in production. We will see that in the next video. So subscribe our channel, don't miss it out. If this helped, drop a like and leave your questions below. See you in the next time.